Welcome back, guys. Today we're going to be talking about corrosion kinetics. We're going to be talking about mixed potential theory and Evans diagram. So let's begin. In a corroding system, there are two main players. Basically, the anodic reaction, where there's metal oxidation, where you lose electrons. Oxidation, Leo. That's when the metal's just getting thinner. And then the cathodic reaction, the opposite. That's when you gain electrons, that's when the metal's getting thicker. And yeah, that's important to know. So now mixed potential theory. What is mixed potential theory? It's basically when an electrochemical corrosion process happens where it's in steady state. So the sum of all the anodic reactions is the same rate as the sum of all the cathodic reactions. Okay? Anodic rates is the same as the cathodic rates. So there's two main things that comes with that. The compromised potential is called the corrosion potential E core. Basically, the voltage difference between the cathode is the same as the voltage difference between the anode. The second thing is the matching rate. That's called corrosion current, I core, and that's when, let's say, the anode rate is really fast and the cathode rate is equally as fast, or the anode rate is really slow, then the cathode rate is equally as slow. So let's kind of visualize all this using an Evans diagram. Here's the Evans diagram. Here is the voltage, the potential, and then it should be a log scale of I, which is current density. Basically, this is just the rate of corrosion, okay? So here is the oxidation reaction, the anodic rate. And remember in the previous video, that slope up I was talking about, it was called passivation. This is the active passivation. Basically, the energy needed to, so let's say that the metal wants to, like, metal atoms want to hop off the metal and go into the water. The energy needed to overcome that barrier, the energy barrier to actually hop into that water. It takes energy to come out of the metal and dissolve into the ions. So that's the hill I was talking about, how much energy you need to get pushed up to the top of the hill. That's the anodic rate oxidation. And then this is reduction, I guess the opposite, to get back from the water ions to get back onto the metal. So you see E core here is the voltage where these two rates are the same. And then I core is the rate where these two are the same, like happening at the same time. So this overall, all this information is kind of telling us the voltage and the rate of how these reactions are when they're equal right here. So what do we want ideally as corrosion engineers? We probably want it to have a lower corrosion rate, lower current density, because we want corrosion to happen slower. So we find ways to maybe bring the reduction reaction like this line if it was right here instead. So yeah, thank you for watching my video. Hope you enjoyed.